In the coffee shop, every employee has an identity. They come into work in the morning and they log into the system to clock in, use the registers, and manage the systems running the coffee shop day to day. We have the cash registers and computers helping run the whole operation. Each person has unique access to these systems based on who they are. If I have Rudy at the register taking orders and Blaine in the back checking on the inventory levels on the computer, they have two different logins and two different sets of permissions. Rudy can run the cash register, but if he went to log into the inventory system, he wouldn't be allowed to do that. You will want to scope your user's permissions in AWS in a similar way. When you create an AWS account, you are given what is called the root account user. This root user is the owner of the AWS account and has permission to do anything they want inside of that account. This is like being the owner of the coffee shop. In this situation, let's say I am the owner of the coffee shop. I can come into the shop, use my credentials to work the register, work the inventory system, or any other system in the coffee shop. I cannot be restricted. With the AWS root user, you can access and control any resource in the account. You can spin up databases, EC2 instances, blockchain services, or literally whatever you want. Because that user is so powerful, we recommend that as soon as you create an AWS account and log in with your root user, you turn on multi-factor authentication, or MFA, to ensure that you need not only the email and password, but also a randomized token to log in. That is great. But even with MFA turned on, in reality, you don't want to use the root user for everything. I, as the coffee shop owner, don't give my level of access to all employees. Rudy on the cash register cannot access the inventory system, remember? You control access in a granular way by using the AWS service AWS Identity and Access Management, or IAM. In IAM, you can create IAM users. When you create an IAM user, by default, it has no permissions. The user can't even log into the AWS account at first. It has absolutely zero permissions. It cannot launch an EC2 instance. It cannot create an S3 bucket. Nothing. You have to explicitly give the user permission to do anything in that account. Remember, by default, all actions are denied. You have to explicitly allow any action done by any user. You give people access only to what they need and nothing else. This idea is called the least privileged principle. The way that you grant or deny permission is to associate what is called an IAM policy to an IAM user. An IAM policy is a JSON document that describes what API calls a user can or cannot make. Let's look at this quick example. In this example, you can see we have a permission statement that has the effect as allow, the action as S3:list bucket, and the resource is a unique ID for an S3 bucket. So, if I attach this policy to a user, and that user could view the bucket coffee shop reports, but perform no other action in this account. There are only two potential options for the effect on any policy, either allow or deny. For action, you can list any AWS API call. And for resource, you would list what AWS resource that specific API call is for. Now, as a business person, you wouldn't need to write these policies, but they are used all over in your AWS accounts. One way to make it easier to manage your users and their permissions is to organize them into IAM groups. Groups are, well, they are groupings of users. You can attach a policy to a group, and all of the users in that group will have those permissions. If you have a bunch of cashiers in the coffee shop, instead of individually granting them all access to the register, instead you can grant all cashiers access, then just add each individual cashier to the group. Same idea with groups in IAM. All right, so far with IAM, you have the root user. They can do anything. You have users, which can be organized into groups. And you also have policies, which are documents that describe permissions that you can then attach to users or groups. There is one other major identity in IAM, and it's called a role. To understand the idea of roles, let's think about the coffee shop. As we know, Blaine works in the shop. And depending on the staffing of the shop day to day, he might work the register or the inventory system, or he might be the one cleaning up at the end of the day with access to no systems. I, as the owner, have the authority to assign these different roles to Blaine. His responsibilities and access are variable and change from day to day. Just because he worked on tracking inventory in the system yesterday doesn't mean that he should be at any time. His role at work changes and is temporary in nature. The same type of idea exists in AWS. You can create identities in AWS that are called roles. Roles have associated permissions that allow or deny specific actions, and these roles can be assumed for temporary amounts of time. It is similar to a user, but has no username and password. Instead, it is an identity that you can assume to gain access to temporary permissions. You use roles to temporarily grant access to AWS resources to users, external identities, applications, and even other AWS services. When an identity assumes a role, it abandons all of the previous permissions that it has, and it assumes the permissions of that role. You can actually avoid creating IAM users for every person in your organization by federating users into your account. This means that they could use their regular corporate credentials to log into AWS by mapping their corporate identities to IAM roles. AWS IAM, authentication and authorization as a service.